Welcome back to a brand new episode of KU Pulse, the podcast. I'm your host today, Hisham Akhtar, and the topic today is really fascinating. We're going to be traveling from Earth to space. It sounds like the plot to the next science fiction TV show, but it's reality, and I'm very curious to learn more about it. I'm super excited to welcome Sai Krishna Nimmagadda, who is a core labs operator, manufacturing specialist at Khalifa University, and the founder of Gulf Space. Welcome, Sai.
Yeah, thank you, Hisham. First of all, I would like to thank Khalifa University for arranging this platform, and it was nice. So tell me, let's go ahead.
Yeah, I mean, let's stay on Earth first and then we'll travel to space.
Yes.
Before we get into the topic, I mean, you're an expert in 3D manufacturing, you've worked all around the world. What interested you about, taking your career towards space? What's your story?
Yes, I would start from since my childhood. I was fascinated about light. So ever since that, I have been fascinating about space, and it all started. And I joined my mechanical engineering. Then I started my career in a Makino. It's a Japanese company. So I learned about precision, how to do things focusedly, where we can get the best output. Then I was into a company, American company, where I found innovation, where we can think beyond, like not the normal one. What next we can do, what further we can go, how to make it more reliable. So I was learning a lot about on innovation, uh, technologies which will give higher efficiencies. Then I was in a uh, German company. So in German company, it was about engineering. That's more connected to me because I am an engineer too. So in engineering, we do the cyclic times. Like when we produce something, say a rover or a machine, the machine should run repeatedly, like say 1,000 times, it's a 10,000 times, like a life cycle. So in German, we have this engineering where we need to be reliable, serviceable, and these things. So this is my journey. Then I entered into Khalifa University.
No, very, very interesting. I think you turned every child's dream into a reality.
Yes.
I mean, everyone's fascinated by stars and the moon when they're kids. But I think, the question is you have all this experience, that you've accumulated, and now you're here. But the real question is why is local manufacturing so important in the discussion for space exploration?
Yes, it's actually self-reliance. Right now, the current technology or capabilities from UAE, we are importing a lot of materials and a lot of components. We can say mostly the components, the space components like the vehicles, the structures, the CubeSats. So here, when we do import, we miss the challenges to update it. We got a feedback. We need to put it and revise it and refine it and have a better one in place. For this challenge, we need to have a local production. Local production is already implementing in a stage where we are mainly focusing on design wise now. So in design wise, we are doing. So furtherly, we need to produce and test locally. This will help us for the local production. And the main thing is in space, when we send something, it needs to face a lot of challenges, different kind of atmosphere, layers of atmosphere, and the biggest one is it should return because we are in the initial stages. We need to take it back. Then once we got it back, we will have some feedback. The feedback has to be applied, and we should have our own manufacturing sectors.
Okay. And I mean, how is the UAE specifically, let's say, addressing some of these manufacturing gaps, or being a leader, let's say, in local manufacturing? And as you mentioned, it's quite important. So maybe you can talk to us about some specific examples that the UAE is pioneering in local manufacturing.
Yes, I have personal experiences. I was traveling around UAE and Gulf, as I said. So I personally visited the entities which are leading the UAE in this space technology. Like I visited Strata in Align. So they were making a lot of aerostructures, the wing structures and honeycomb structures. And also I visited, before it was called Tawazun Precision. So they were manufacturing some defense and aerospace, both related sector. Now it is Edge Group and Halcon Systems. So Halcon Systems are also working on robotic manufacturing. They are pioneers in robots actually, because from decades they are working on robots and how robots can improve the manufacturing, because space components have a very three-dimensional one. So you have a complexity in the design, and conventional one is difficult. When you have a robot, it is like replication of a human. It can articulate in different degrees, and this is UAE has doing a lot. Even they have set up one special economic zone for space in Masdar city, and they are pioneering in solar energy, because in space solar energy is the key component for day-to-day activity when the sun is present. And similarly, they are working on artificial intelligence to have the revised designs, advanced simulations, feedback. So UAE is doing a good thing as of now. They are collaborating internationally as well, even with Indian ISRO and other organizations of NASA, and they are collaborating even with Russia Roscosmos. So they have been training in all aspects.
So quite a collaborative effort when it comes
Exactly.
to space exploration. Is it just a cost component, local manufacturing, or do you think, especially here in the UAE, we are looking at producing materials that don't exist yet? Like, is that aspect also important where new discovery, you mentioned that innovation part.
Yes.
So are there any, really exciting projects or things being developed within the UAE that we aren't seeing anywhere else at the moment?
Yes. Coming to the cost point, like right now, it's a visionary. There is no cost component involved, because space tech is mainly for the humanity to reach beyond. So, on materials, definitely, like you said, some materials are available in some areas. Like there is some material tantalum. So this tantalum is one of the material which can withstand high temperatures above 3000 degrees Celsius. These materials are crucial for re-entering from the space, because when we re-enter from space, there are so many characteristics which force us into temperature and friction and resistance. So definitely materials, we need to source it, but still investigation is going on how to produce the local ones. But most of them are aluminum alloy based, and UAE is pioneering it, because UAE is one of the leading exporter for aluminum extrusions and aluminum related products. So they already have a hand in it. It will definitely do best for them.
Very, very interesting. And, now let's say the tools are being developed on Earth, whether they already exist or we're finding them using AI, as you mentioned. I think the big question for our listeners is, can you actually 3D print buildings or structures, in space using spatial material? So like dust from the moon, rocks, things like that. So enlighten us a little bit about that. Is it actually possible? If so, how?
Let me give some insights about 3D printing in current scenario, what is going on. Then I will take it to you the further way. In 3D printing, it's like additive manufacturing. So conventionally, what we are doing is a subractive manufacturing. It's like making a statue from a stone. So we are just removing the parts and making a beautiful statue. It's the same conventional technique we are using for current generation of components, machines, and things. Whereas 3D printing, it comes in a different perspective. It's like human organism, how it generates from single cell. So in 3D printing, we take some simple raw material, it's not multiple ones, just simple raw material. Then we fuse it, we fusion it with a heat source mainly. So we take fine powders, we deposit in layers, then we fuse it layer by layer, layer by layer. So you craft it. What you craft in layer by layer, so it gives the best one. So right now for 3D printing in moon, we will replicate the same in space. We looking at the space dust, the moon, like you have a regolith on moon. It's a dust of moon soil with fractions of broken rock and some materials and some crucial materials which we can fuse together with our ionization technology. Then we can build structures using the regolith into a domes. So the domes, typically the domes, because it will reflect the radiation, because there is different atmosphere. So our designs for 3D printing has very flexibility. The conventional, we cannot reach the tool on the up or down or some crucial areas. But in 3D printing, the flexibility is more. You can have a different flexible designs like the dome structures and complicated intrinsic designs we can do. So definitely 3D printing is the future. It will provide us from the local in situ resources. We can collect it and we can apply the technologies and build it.
Okay. And I mean, just digging deeper a little bit on this. So there's obviously learnings from here that we can apply there, but do you see us also discovering new things from there that we can apply in 3D printing, at the moment and advance that technology much quicker?
Yeah. Your question is absolutely right strike. Like in Earth, we have different layers of atmosphere. We have the gravitational force like 9.8, and in planets like asteroids and in the moon and all the other planets like Mars, there are different scenarios. There are different atmospheres. So there are low gravity, like we have here 9, there it is only 1. And also atmospheres are different. So it can be, energy can be very beneficial. Like in Earth, we have some gravitational force. So the energy what we required is more energy. So in low gravity, the same energy what you use here, it will give you 10 times, 100 times the same. Like if I jump here only 3 feet, there I will jump 300 feet. So these scenarios, and also there are so many impacts on space. So when there is different impacts, we get different materials, and which is not possible on Earth. We may have to recreate the same scenario on Earth. So definitely it's a treasure for us. Space is a treasure where we can get different, even the electronics industry, the silicon conductors, it can be added with the best conductors where it can withstand high temperatures, and we can give signals, very high signals, where we can reach into deeper space. So we have different materials in space.
Yeah.
It's a treasure hunt.
Yeah, and I'm sure, artificial intelligence and advanced computing is really helping us map out and understand all of these discoveries we're making in space. Okay, we're able to build structures, we're able to use resources, materials from other planets. Then the question becomes, what are the challenges for us as humans to, let's say, move or start using those habitats that we create? Because as you mentioned, gravity, I mean, we don't want people just jumping around the planet, right?
Yes.
So beyond that, but like from an atmosphere perspective, environment perspective, what challenges do you foresee in mass adoption of these habitats that we will create in the future?
Yes. Like you said, it should be controlled system. Like because there are different scenarios, different atmospheres which are unknown. And so in space, our colonization will be a closed loop system. So we will have everything generated, everything repurposed, recycled, reused. So in the colonization, our target is there will be minimum leakages or zero leakages, and it has to be recreated and repurposed. So here we build the structures, and the structures will be like monolithic structures, like it's a single built from very few variable parameters like simple dust and like simple fusion. So we eliminate number of parameters. So we have a control on the design, and we can repurpose the materials. So here it goes like closed loop system. We have to safeguard the system, because in Earth we have learned already. There we are learning. So it will take some unknown challenges. We have to be prepared in next level. Here in Earth, you fail, it's okay. You can do.
Yeah.
There you fail, it's done.
Yeah.
Done and dusted. So
There's a lot of movies about people stuck in space, so we don't want that to become
Yes.
a reality.
Yes.
But I mean, can we create those similar environments on Earth to develop and refine these closed loops you're talking about? So like doing
Yes.
pilot projects, so to speak, before we start implementing them in space. Do we have that capability?
Yes, yes. Right now, whenever I go to the desert, Liwa Desert, and nearby deserts in UAE, I was fascinated by the red sand. It's beautiful. I even get family pictures. So this red sand, it mimics to Mars. So we have a similar sand and similar some dust storms happening in the deserts. So UAE has best place to mimic the planet Mars, having a dome and having like recycling the resources. It's going to happen for sure, I believe.
So no need to travel so far. We can just go to Liwa and get that same experience.
Yes.
Okay, so now we've built the tools, we've developed these systems, these closed loops and everything, but space is unexplored territory, right? So how do we go about starting to define who owns what? I've heard stories, I've read some reports, you can buy a piece of land on the moon, but whose is it to begin with? So talk to us a little bit about, what the discussion is around ownership in space. There were some treaties that were signed a lot of years ago, but are they still applicable? Do we need a new framework? How do you see it happening?
Yeah, starting with maybe I was not born, maybe you are not born. There is a treaty.
Yeah.
It's International Treaty for Space Organization. So it was in 1960s. It's there, and it's still very decades back. It need lot of redrawing the agreements and all. So we can just keep it as a collaborative one. So as of now, the treaty says it's collaborative, and whoever goes first and whoever controls the data, like even we travel to moon, to Mars, we need communication because we are developing it. So generally the communication and the data holding gets more power. So these treaties and these things, like if I go to space, I'm Indian, like you go on Arabs, Americans, Russians. So, but finally we will become either Martians. So we will all become united together.
Mm-hmm.
So we will have to develop our own local policies. And like you said, there was even I have seen some news like there is some structured organization about moon and Mars. But as far as I believe, these all are for making a map, like layering it and making it a map to identify the place, to identify the locations, the area on the planets. So it's not for the ownership. So as of now, it is for identification, and we keep going and developing with multi-country collaborations.
Okay, so you're seeing collaborations continuing in space as well.
Yes, absolutely.
Definitely. Okay, so as I mentioned, space, uncharted, Mars, we've seen some things around the atmosphere and things like that. If you had to develop, let's say, what lessons we should take from Earth, onto Mars, I'm sure there's a lot, but we're a little limited on time. So some key things, establishing, as you mentioned, those closed loops. What are some things we should keep in mind while we're building these space colonies? Let's call them that.
Yes. Like I would say, it's a give and take policy. So space has given us actually a lot because we get the energy from the sun. It's continuous. And also when we were venturing into space tech and the innovations we got, NASA has given many legacies, even our day-to-day life. Like we are using the mobile phones with the tempered glass, which is one form of very resistant and high temperature one, which is useful for re-entering from space to Earth. And similarly, like the GPS, we are using for navigating. So these technologies have come from on venturing into space. So when we go from Earth to other planetaries, so we have learned a lot of lessons here, like the climate changes, the diseases of COVID, and how it can be entering into our system, how to tackle it. So these learnings we need to continue there and apply there in very rigid manner.
Yeah.
So,
Yeah, because I think it will always be easier to implement these policies while we're building.
yes.
Because on Earth, as we've seen, sometimes it's reactive rather than proactive. But very, very interesting. So it's very much possible for us to be in space, maybe sometime soon. You're an entrepreneur as well. You're working on Gulf Space, and it's very rare we get the chance to talk to an entrepreneur who's working in space tech. So tell us a little bit about what you're working on, and how that ties into the whole discussion that we're having today.
So in Gulf space, we are looking at space components. How do we reduce the number of parts? It's the same conventional methodology where it will be 1,000 parts on the rocket components. Also in the rovers where there is a wheels and attachments. So in Gulf space, we are focusing on 3D printing, design, and like it will be like monolithic structures where single material, single parameter, and less number of components.
Okay. So, I mean, it might be possible that Gulf Space becomes one of the first infrastructure developer in different planets. But I mean, you mentioned, reducing the number of parts. How is that important, or why is that important when we talk about space exploration?
Yes. When we go in single part, we have the control. When we go in multiple parts, there will be a joineries and there are weak points. We do simulations to understand these conditions. So when we do simulation, the main problem comes on the joineries. When we join one, there will be a gap. So in the gaps, because these are very highly impacted structures, so you will have leakages, and the leakages will multi-factor it, and there can be explosions. So we need to reduce the number of components as much as possible and go for the solid thing like welding, and instead of a joinery, it should be a fusion. It should be a fusion. So this is the main part which is crucial for making a structures which can go successfully and come back. Also, it will help us on reducing the mission times from say Earth to Moon. We have to reduce the number of days for the machine time and come back, reutilize it, repurpose it. Efficiency has to be improved.
Okay, so it's not just that 3D printing is a cool technology to apply. It has very important aspects to space travel.
Yes.
In terms of safety, in terms of, like you mentioned, re-entry, and reducing travel time. So we've had a very fascinating conversation today. Time flies, but what do you see as the future of space colonization? What's the next 5 years look like? Do you think we'll have the next KU Pulse episode recording, sometime on Mars? Is that a possibility? What's exciting you about this whole discussion?
Space is definitely promisable. Definitely. It's going to be step by step process, and definitely first stage will be the systems of traveling in the orbit, the space stations, which we have already, but it will be numbered more from the collaborating countries like UAE is planned for 2060, and India and Chinese and American, Russian already have their space stations. So we will have the orbiting stations initially. From orbiting stations, we will be traveling to the moon. So then we will develop the structures locally, and it seems quite possible, but not in like 5 years. But sure, in our lifetimes or in our children lifetimes, this is a journey for sure in the future.
No, very, very exciting. Sai, thank you so much for joining us today. It was great. We talked about everything from building the tools locally to building habitats on Mars using sources and sand and rocks that we find on those planets themselves. And that's really, really exciting. And not just that, you're helping actually build the components and parts that will take us to space one day. So thank you so much for sharing your knowledge. It was a very insightful topic. To our listeners, if you found the discussion interesting, please subscribe to KU Pulse the podcast on YouTube, Spotify, and SoundCloud. We hope to keep the conversation going. And until next time, stay curious. Thank you.